we're going to go through a subroutine example, and the reasons you might use a subroutine are you might want to be breaking up your program into different logical chunks to make it easier to read and manage. And another thing is you might want to be designing these subroutines so that you can use them in other projects. They're a reusable component you can bring in. So we'll go through, in this example that I've already created, we'll go through it, and it's kind of designed in a way that in a format that we see very commonly and would highly recommend you implement. So subroutines, just like everything else we do, we want to have them enter their routine, check some logical states, respond to however they need to, and then move back on. Go to your main loop and check the important stuff there. What we want to ensure is that we're never locking up in a particular condition that prevents us from checking valuable maybe inputs, the states that may be very important that we need to be checking on all the time. We don't ever want to lock ourselves up in a case where we're ignoring those. So in this case, we've got a main routine, and we'll go through it, and we've got a subroutine. So this main routine, it initially puts a value into a state, and we'll talk about that in a minute. But right after that, it checks a condition. And in this case, this is something our routine we've decided is important, and it needs to happen. We need to be looking at it all the time and responding to it. So we're calling this door button 1, and if it's on, we're going to turn on door 1 and turn off door 2. And if it's off, we'll turn off door 1 and on door 2. And then we'll move on with the rest of our code, and it happens to consist of a state machine. But you'll notice at the end of every state, we are looping back here. So this operation is happening all the time. And in the state, when we're using state machines, we've got some other operation that can be broken into a number of steps or states, and we chip them off one at a time, and that's what they're doing. So with the state machine, the first thing I did in the program is I put a 1 into state, and you'll see that it is not inside the big loop. So it just occurs the very first operation of the program, then it goes here, and it's stuck in this giant loop that does all the important stuff from then on. But the first time it gets to this point, it's going to ask is state equal to 1, and it will be. And what we're going to do is we're going to set a value that'll be important in our subroutine. We're going to put a 1 into substate. So that's how we're going to initialize a state machine inside of our subroutine. And then we'll put a 2 into state so that next time it loops through the big loop, this case will be true, and it'll end up going into our subroutine. And you'll see we don't have a copy state at the end of this that like we normally would to advance the state to, in this case, state equals 3. That's because we're going to actually pass in the state, and we're going to do it in a way where we can modify that inside our subroutine. So when the subroutine's done, the subroutine's actually going to advance the state to state equals 3. And when it comes through, it'll go here, and in this case we're going to wait for a flag to be true, which will cause us to start the state machine back at 1. So it kind of reset our state machine in this case. Now we'll go ahead and we'll jump into the subroutine, and we'll talk about how it functions. The main thing to notice here is that the state machine, it looks pretty similar to the one in the main routine, with one key difference. After every state, whatever the conditions that are checked and the operations that are performed, it immediately will go to a subreturn. And what that does is it exits, and it goes back. It'll exit this subroutine, and it'll go back to its main loop. And it's for the purpose of, again, we don't ever want to lock ourselves up in a condition. And I'll show you an example of locking ourselves in a condition. We've got a timer we're waiting on to increase to 100 milliseconds here. If I looped it back around to itself, we would be stuck here for 100 milliseconds. And in that time, we're not doing anything else. And in this example, we've deemed checking this door button as a critical part of our task. So we'd be ignoring that, and that could be, depending on your application, that could be of a safety concern, or it could just be a very important piece of your operation. So you never want to loop something around or have a condition where you're locking up your program. You always want to get into your subroutine, check a condition. If it meets whatever your requirement is, go ahead and do an operation and then exit. And if it doesn't meet the operation, just go ahead and exit, because you'll get a chance. You can keep entering your subroutine over and over and over. Scan times are often around 5,000 per second, so you can very rapidly, you'll be going in and out of these subroutines. You just don't want to lock yourself up. Okay, so in this state machine, like a lot of state machines, when I design them, I go ahead and I start at my timer if there's some time component to it, and there's no risk to constantly entering this and constantly hitting the start. Once it's started, it's started for until you stop it. So it's just going to keep going on its own, and throughout the code, I can reset that timer. And every time you enter your subroutine, it's going to keep on from it's going to keep up with its current time. So by exiting the subroutine, it's not resetting, it's not pausing that time. It's continuing to go on in the background. Okay, so here we've got a sub. We're asking a sub equal to 1, or is sub state equal to 1, and we know it is because you might remember that we put a 1 into sub state, and then we passed the substate value into substate. So it is 1 at first, and then the thing we're going to accomplish with this particular subroutine is we've got an actuator that has 4 settings bits, and in this case, you see in state 1, I'm going to copy some values into this actuator setting 1, 2, 3, and 4, and then we're going to wait 100 milliseconds, and then this actuator, after that amount of time, we're going to send it a flag, a 1 bit that tells it to go ahead and operate on those settings. So it'll do that, and then we're going to, at that point, we're going to wait around for a limit switch to happen, at which point we will consider, we'll go ahead and stop that run flag, and we will tell our main routine to go advance to the next, to its main next step, because we're done with what we're trying to accomplish here. So we'll go through a few of the details here. So when substate is equal to 1, we're going to copy in those settings bits that we discussed, and then we're going to also advance the substate. So next time we go through, it'll be substate equals 2, and we're also putting a 0 into timer, as we've done in other examples. That's a quick way to reset the timer. It is functionally equivalent to selecting the timer and hitting the reset. Putting a 0 in it is exactly the same thing. So it's reset, so it's going to start off at 0, and we're going to just keep comparing the mine timer to 100 milliseconds, and when it finally reaches it, we'll go to here, where we will set the run bit, and then we will advance the substate to 3. It'll get here, it'll wait for the limit switch, it will turn off the run bit, it will advance the substate to a state. You just see we don't have a substate equals 4, it would just fall through here and hang out. And then we're going to advance the main routine's subroutine, and that's going to do what we talked about earlier, where it's going to advance the state to 3, so it'll continue on. So how do you actually change the value of things from your calling routine, which this is where we're calling our subroutine, and you see we have it selected here. How do you change the values that are being passed to the subroutine? Well, the way you do it, up here we define what else passed into our subroutine, and you can pass each piece of data one of 2 ways. You can either do it with this single arrow, which is by value, or this double arrow, which is by reference. And the single arrow, it takes the calling routine and it dumps that data into the subroutine, into its tag, whatever you have named here. But when the subroutine exits, it doesn't do anything to the calling routines. So in this case, we're just doing that with one piece of data. We've got this limit switch. So if you've got the limit, you see that I'm passing in bit C6, I'm passing it in by value to limit, and whatever happens in the subroutine to limit, maybe for whatever reason it's changed, it's not going to have any effect at all on in bit 6 because it was just by value. Now we have the other way to pass it, which is by reference. And the way that works is, so you pass in from the calling routine into the subroutine. You pass it into whatever the tag is here. And when the subroutine exits, it goes ahead and copies whatever is in that tag. It copies it back to the variable associated in the calling routine. So it's actually changed in the calling routine. And that's, you can see when I am calling this subroutine, I'm passing in some output bits. So I'm actually wanting these outputs to be changed by my subroutine. So it's important that I allow the subroutine to modify them. So when act setting 1 goes high in the subroutine, that's going to cause, as soon as the subroutine exits, it's going to cause output E1 to be high. And okay, so that's how you pass your data. And we've already gone through how you want to make sure you always are exiting immediately, and then going through all of your critical operations. And that's the basic format that we recommend you try when using subroutines. Thank you.